Here are the solutions for the mock exam on logic. Number one, let the propositions P, Q, and R be defined as P, Matthew arrives home before 6 o'clock. Q, Matthew cooks dinner. R, Jill washes the dishes. Express the following statement in logical form. That just means with symbols. If Matthew arrives home before 6 o'clock, then he will cook dinner. Matthew arrives home before 6, that's P. He will cook dinner, that's Q. If then, we write like that, right? So P implies Q, or if P, then Q. Write the following logic statement in words. It has a not Q, therefore not R. So we could say if then, or we could say therefore, or we could say implies. So if not Q, so if Matthew does not cook dinner, then Q would be, or not R would be, Jill does not wash the dishes. Jill does not wash the dishes. Next time I'll type it. Okay. Copy and complete the truth table below. Okay, so this is just like a pure truth table problem. It's kind of challenging because it's got the implications in it. And the implications, remember, true goes to true. Now, if true goes to false, then that would be invalid because when the first part is true, then the second part must be false. And if it's false, goes to anything, that's fine because we never said what happens when the if part is false. Okay. So let's look for that. Is there any place where P is true and Q is false? Yes, here. There and there. P is true, Q is false. Those are invalid. Everything else, for example, when P is false, all those are fine. They're valid. When they're both true, they're also valid. Okay, moving on. Q implies R. So now we're going to look at these two, for example. When they're both true, that's fine. When either one is, or when the Q is false, that's also fine. These are also fine. Those are both true, so that's fine too. Now when Q is true and R is false, then that's invalid. Okay? Alright. Now, not R, that's an easy one. Finally an easy one. You just reverse everything in the R column. Alright, now we're going to combine some of these. So this is actually combining this one, and this one, combining them with ands. When you combine something with and, they all have to be true for the whole statement to be true. Are there any of these where everything is true? Just this one? None of the others have three truths. So this is true, this is false, 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 false. Okay, then we do not P. That's an easy one. Not P would be just you take the opposite of all these. So the first four are false, and the next four are true. And then let's just check to see if this is true. They've already filled this in for us. They say if we take this statement here, the left side, and we do an implication to not P, that we're going to get all T's. Is that true? Well, let's see. We have double falses here. Those are fine because with an implication, if the left side is false, the right side can be anything. And then here, we also, the next three, we also have false on the left. So the right side can be anything. And then at the very last position, we have both true, which is also fine. So this worked out. We probably have everything right now. Explain the significance of the truth table above. When they say explain the significance, I think they want the meaning. So what we're going to do is we're going to translate it back to words. If we look at P implies Q, that's if Matthew comes home before 6 p.m., then he cooks dinner. That's the first one, P implies Q. Then we have Q implies R. If Matt cooks dinner, then Jill washes the dishes. Jill, and then we and that with not R. Jill does not wash the dishes. And then we could say therefore, not P. So Matt did not come home before 6. Okay? I think that's right. Yeah. Okay? So that's what that means. And the truth table shows that this is valid, that it is a tautology. Okay, moving on. Let P and Q be statements. Sarah eats lots of carrots. Sarah can see well in the dark. Write the following statement in words. P implies Q, or if P, then Q. So if Sarah eats a lot of carrots, then she can see well in the dark. That's easy, right? Now do not P and Q. So Sarah does not eat lots of carrots, and she can see well in the dark. Okay? Write the following statement in symbolic form. If Sarah, Sarah cannot see well in the dark, that is the negation of P because, oh no, wait, that's the negation of Q because Q is she can see well in the dark. So she can't see well in the dark would be not Q, okay? And there's an if too. Then she does not eat lots of carrots. Sarah eats lots of carrots is P, and not eat lots of carrots would be not P. And then they have an if then, so that means there's an implication. So that's all it is. All right. Is the statement in part C the inverse, the converse, or the contrapositive? Now let's see. When I did the exercise, I kind of started to remember which was which. Okay, so the first one we always did was the converse. The next one was the inverse, and the last one was the contrapositive. It's the most complicated. The converse is just like, okay, if the statement is P implies Q, the converse is just the opposite. Q implies P. The inverse is like the negative. So instead of P implies Q, you're going to have not P implies not Q. Okay, that's you modify that one. The contrapositive, you're actually taking the negation of this one. So it's actually not Q implies not P. Okay. Now if you have left and right side that are equivalent, then what you end up with is like any one of these converse, inverse, contrapositive, they're all valid. Okay, so now which is this one here? It says not Q implies not P. Not Q implies not P is the contrapositive. Oops, I typed in the wrong thing. Positive. Okay, so that's it. That was the test. You can see that when you're comfortable doing these, it's really quick.